All right. Today we are going to use our arrow diagrams, our parent functions for sine and cosine to model a sinusoidal situation. So our problem here is one about varying temperatures in a city. It says the temperature varies between 10 and 58 degrees on a typical day. We'll ignore the misspelling of assume in there, and we'll assume that the temperature at 2 p.m. is 58 degrees, and the problem is to find an equation for the temperature T in terms of the hours since midnight, and that variable will be X. All right, so the way that we start this situation is to kind of get ourselves a little graph going, okay? And we'll mark the things that we know. We know, for example, that at 2 o'clock in the afternoon, and I ignore that bell for a second, we'll let it keep ringing. At 2 o'clock in the afternoon, the temperature is 58 degrees. There doesn't have to be a tremendous amount of accuracy in this, but we know that is the high temperature. And so that would mean at 2 o'clock again the next day, so this is 2 p.m. At 2 p.m. the next day, it would be back up to 58 degrees again. And the low temperature is 10. That would happen 12 hours after 2 p.m., which would be like 2 o'clock in the morning that would happen. And so we had a low point right there. And then we know that there should be some halfway points in here. We should have this broken up into nice 4 pieces, halfway between 58 and 10. If we do 58 plus 10 divided by 2, 68 divided by 2 is 34. So our axis of oscillation is going to go through here at 34, and 6 hours after 2 p.m. there's going to be 8 p.m. This will be 8 a.m. that we hit these. It's cooling off at that point. It's warming back up at this point. And so our curve to represent this should look something like this. Okay, probably curve that off a little bit more like that, which we recognize as the basic shape for our cosine function. Now the only other adjustment that we're going to need to make here is that the variable is supposed to be hours since midnight. So 2 p.m. is 14 hours since midnight, and 6 hours after that is 20 hours after midnight, and 26, 32, and finally 38 hours after midnight. These look a little funny like that, but we're going to be able to use those to do the problem. So now that we've determined that this is the basic cosine shape, and what we do is we bring our cosine function in, and we figure we may need to make some stretch and shift vertically, and we may need to stretch and shift horizontally as well. We'll bring in the points that we actually know. So our key points on the cosine function are at 0, at pi over 2, at pi, 3 pi over 2, and 2 pi. And this is the high, middle, low, middle, high for cosine. And where we want these things to line up, we know from down here that first high point is supposed to happen when the x is 14, and then 20, and then 26, 32, and 38. And we'll grab another color over here and shift this out of the way one more time. And the high point, again, we said is supposed to be 58. The middle is 34. The low is 10, back to the middle of 34, and back to the high of 58. So if we look at this, let's look at the output side here first. One thing I notice here is we can read the amplitude off of there, and it says our amplitude here is 24. Okay? Our amplitude over here originally is just 1, so we need it to be 24 times as tall. So we will multiply by 24. And if we do that, go ahead and multiply by 24, we get a 24 there, and a 0, and a negative 24, and a 0, and a 24. And if we look at what's left, particularly right here, I can see that if I just add 34, 0 plus 34 is 34, 24 plus 34 is 58, negative 24 plus 34 is 10, so that is the right thing to go there. Right, if I come over on this side, I notice that my gap here is exactly pi over 2, or I could look at this in a number of different ways, but I'll say that gap is pi over 2, and this gap over here is 6. And so the question, I'm going to scroll this down a little bit, is what do I multiply pi over 2 by to get 6 as an answer? And solving that equation, I get 12 over pi. So this should be multiplying by 12 over pi. So I'll do 12 over pi times that. 12 over pi times 0 is 0. 12 over pi times pi over 2, the pi's canceled, the 12 over 2 becomes a 6. 12 over pi times pi is just 12. 12 times 3 is 36. The pi's cancel again, divided by 2 gives me an 18. And 12 over pi times 2 pi gives me a 24. And I can see to change this list of numbers into this list of numbers, I just need to add 14. So working back across the top then, that's a subtract 14, and this is a multiply by pi over 12. And I should now be able to create my equation by just reading right off of there. If I start the whole thing with my x right there, I get this thing out of the way for now. A little farther out of the way so I can see my equation. I start with the x, and we subtract 14. We multiply that whole thing by pi over 12. It all goes into a cosine, which I then multiply by 24 and add 34 onto it, and that should give me the temperature X hours after midnight. And we'll work in another video on how we would pinpoint a particular temperature, how we would solve an equation that looks like that in the first place. But that is all that takes.